Assalamualaikum and good afternoon. We are looking at two problems that was given in the calculation assignment, and the problem are number 4. Question number 4. An aircraft battery is rated 24 volts and 32 ampere hour. What is the potential work in joules that can be produced by the battery if the capacity is 100%? And number 5. This is on the internal resistance. A battery 1.5 volt with internal resistance 0.2 ohms is connected to an external resistance of 5 ohm. What is the power generated by the battery and what is the power consumed by the 5 ohm resistor? Let's look at the first one, number 4. Okay. Number 4 is quite straightforward because this is a power calculation. Look at first you got to calculate the power, and then the power times you get the work done. The power calculation for battery and also DC is volt time current, volt time amperes. In this case, 24 volt battery and it is 32 amperes. So you get 24 times 32 watts. To calculate power, to calculate the work done, then you got to time by the times. So the formula is V times I times time equal to 24 times 32 times 60. This is because time was in hour. Look at this, the time was ampere hour. So the hour you got to convert to second. So the 1 hour times 60 seconds times 60 minutes. And you have about 2.764 million joules. And of course, you can do this, you can convert this into kilojoules. Let's look at the second question. This is on the battery 1.5 volts. Internal resistance is 0.02 ohms and the external resistance is 5 ohms. We got to find out the power generated by the battery, which is in fact the total power given and received by the loads, and the power consumed by the 5 ohm resistor. For this question, the first thing is we have to draw the circuit first. Without drawing the circuit, then we cannot see the full picture. You have the battery 1.5 volts, you got the internal resistance 0.2 ohms and the external resistance 5 ohms. So then we have the total resistance RT is equal to R internal plus R external is equal to 0.5, 0.2 plus 5 ohms is equal to 5.2 ohms. Then you calculate the current. Therefore, I, let me get it, stop for a second. Then we calculate the current. I is equal to V over R total is equal to 1.5 volts divided by 5.2 ohms. 5.2, and the answer of course in amperes. This is the amperes. And you will get your answer in the 0.288 amperes. 0.2. Now that we know the amperes, then it will be easy for us to calculate. Then let us calculate the power given by the battery. So the power given by battery, the power by the battery is equal to the total power. The power given by the battery, PB, power by the battery, is equal to the total power of the loads. Because you have whatever the battery gives the power, then the load will take it. So it will be the total resistance. So the I squared R, which is the total, is equal to 0.288 squared times 5.2, and this is in watts. So the answer you will get is 0.432 watts. And then the next question is, what is the power consumed by this resistance? Then the power by resistance equal to I square R times the resistance is equal to 0.288 squared times 5. Then you will have the answer 0.412 watt. 414 watts. 414 watts. Okay, we stop a while, and this is the total the work of calculation for number 5.